Okay, so let's go ahead and take a look at this next lesson. This next lesson is probably one of the most important lessons that you guys can do in this particular unit. I am like 90 to 95% sure this is going to show up on the AP test, and it'll show up on the free response. So I'm going to do everything I possibly can to test you as many times as I possibly can on doing what we call solving the initial value problem. It is super important that you follow the directions that I do, because if you skip a step or you miss a step, you will run the risk of earning no points. Okay, so I'm going to be very specific on this particular objective when I grade it for your problem set. When I grade it on a quiz or a test, I'm going to be very specific, and if I don't see certain steps, and I will tell you what those steps are, you won't get points. Okay, so solving the initial value problem means to find the original equation. Okay, so the first thing that you have to show is what we call separation of variables, which is taking your x terms and moving them to the right, and taking your y terms and moving them to the left. It has to be x to the right and y to the left. And you're taking the antiderivative of both sides. When you take the antiderivative of both sides, you will get a plus c. You don't have to write plus c on both sides of the equation. You only have to write it on one. So I only will write it on the right side of the equation. Antiderivative of dy will be y. Then I have antiderivative of 9x squared, so 9 times 1/3 x cubed minus 4 times 1/2 x squared plus 5x and plus c. So y is equal to 3x cubed minus 2x squared plus 5x plus c. Now you have to solve for plus c. So I'm going to use my initial condition, x is equal to -1 and y is equal to 0. So 0 is equal to 3 times -1 cubed minus 2 times -1 squared plus 5 times -1 and plus c. When I simplify this out, I get c is equal to 10. So then I rewrite my equation, y equals 3x cubed minus 2x squared plus 5x and plus 10. And that is my answer. If I do not see the separation of variables, you get no credit at all. If I do not see you plugging in the initial condition, no matter how easy it is, you only get half the points possible. So it's very, very important that you show as many steps as you possibly can. Okay? Next example comes directly from a free response question. Consider the differential equation dy dx is equal to 1 plus y over x, where x is not equal to 0. Find the particular solution, y equals f of x. That means the original equation. Given the differential equation above with the initial condition of f of -1 is equal to 1 and state its domain. Okay, so step 1, separation of variables. I move my y, or 1 plus y, to the left side, and I move my dx to the right side, and I'm taking the integral. Then, taking the integral of 1 plus y, u is equal to 1 plus y, so du is equal to dy. V is equal to x, so dv is equal to dx. So this gives me the ln absolute value of u, and this gives me ln absolute value of v plus c. So this is the ln absolute value of 1 plus y is equal to the ln absolute value of x and plus c. It's up to you when you want to find out your plus c. I will find plus c here first before trying to isolate y. The one thing that you have to do in this particular section is you have to isolate y. What does isolate y mean? Y has to have a coefficient of 1 and exponent of 1, and by itself. So no, nothing being added or subtracted to it. Okay, so I'm going to use my initial condition. land absolute value 1 plus 1 because that's the y value, land absolute value of negative 1 and plus c. I'm getting that because f of negative 1 is equal to 1. So I get the land of 2 is equal to the land of 1 plus c. The land of 1 is 0. So c is the land of 2. Okay? So now I have land absolute value 1 plus y is equal to land absolute value of x plus the land of 2. Properties of logarithms would tell me that this addition symbol here means that I multiply. So land absolute value 1 plus y is equal to 2. Sorry, not 2. Land times 2. Land of 2 times the absolute value of x. Sorry about that. So my 2 and my absolute value of x get multiplied together. Another property of logarithm states that if I have both land on the left and on the right and they have the same base, which both of them have the base of e, that I can drop the land and set the arguments equal to each other. So the absolute value of 1 plus y is equal to 2 times the absolute value of x. Now this is where it gets a little tricky. Remember rules for dropping the absolute value bar. You have to always make sure that your result will result in a positive number. So what we do is we look at the initial condition. The initial condition plugs in a negative 1 in for x and a 1 in for y. So if I always plug in positive values in for y, then I can just drop the absolute value bar and get 1 plus y. Now what happens with my absolute value of negative x? Well, if I plug in my initial condition here, I get a negative result. So I have to multiply this x by a negative 1 when I use my initial condition. And so y is equal to negative 2x plus 1 if x is less than 0, which is why I have a domain restriction there, because I am choosing, based upon my initial condition, that I'm going to plug in negative values in for x, not positive ones. And what you notice is that my solution here that I have, my y equals negative 2x plus 1, y is by itself, so nothing being added or subtracted to y. Y has a coefficient of 1 and an exponent of 1. If you want to receive all of the points possible, you will have to write all of your equations this way. This is worth up to like 7 points on a free response test. So this is really, really important that you spend the time going through this and getting it right. Okay? And that is it for this lesson.